What's up, everybody, and welcome back to OpenStax Chapter 3, Section 1 in Calculus, defining the derivative. Let's do it. For number 1, we are finding the slope of the secant between x1 and x2. So again, slope of a secant, it's just the slope of the 2 points where the x values are 2 and 5. I'm talking about for number 1. So what we have to do is we have to find the corresponding function values and then calculate slope. So first I'm going to plug 2 into this linear equation. 4 times 2 is 8 plus 7 is 15. We plug in 5, we've got 5 times 4, which is 20 plus 7 is 27. So now I have my 2 coordinates. Now we're going to calculate slope. So we're going to take the difference of the y values. I'm going to subtract down 15 minus 27 over the difference of the x values in the same order, 2 minus 5. And 15 minus 27, is negative 12 over negative 3, which is equal to 4. So the slope of the secant line is 4. Now, this makes a lot of sense because this was a linear equation to begin with. So the slope, no matter what points we choose, should always be 4, but there's verification. That's how you do it. Done. Now we want to get, for number 7, the slope of the secant where x is 1 and x is 16. So I just need to find the corresponding function values and then calculate slope. So I'm going to plug in 1 here for x. Square root of 1 is 1. For 16, square root of 16 is 4. Okay, so now we're going to subtract down and calculate the slope. 1 minus 4 for the run, and on the bottom, 1 minus 16. Or sorry, that's the run, this is the rise, excuse me. 1 minus 4 is negative 3. 1 minus 16 is negative 15, which means my slope reduces to, that's going to be positive 3 over 15 reduces to 1 over 5, right? Divide top and bottom by 3. And we get a slope of the secant line of 1/5. That's how you do it. For this one, we are trying to find the slope of the tangent line and then eventually the equation of the tangent line. So first, we're going to find the slope of this tangent line at a equals 2 using the definition of a derivative. So we're going to say limit as h approaches 0 of f of x plus h minus f of x over h, okay? And since we already know our a value being 2, we're gonna modify this a little bit. We're going to say that we're gonna plug the a value in directly right into this formula. So we've got f of a, but we know a is 2, so I'm just gonna say f of 2 plus h minus f of 2 over h. All right, now let's plug and chug here, right? So we've got 3 minus 4, and in place of x, I'm plugging in the 2 plus h, boom, boom, minus f of 2, which is 3 minus 4, replacing x with 2 over h. And again, we're still taking the limit as h approaches 0. All right, now let's simplify. So we're going to distribute that negative, and we've got 3. Negative 4 times 2 is negative 8. Negative 4 times h is negative 4h. And then we got minus 3. And then that's going to be a negative 8 times a negative is a positive 8. Okay, we know we got h in the denominator. I'm not going to write that just yet because we'll put that in later. So now these guys cancel out pretty nice. These guys cancel out pretty nice. So now we're left with negative 4h over h. Now this is a great situation because the h's are going to cancel out, and we're left with this number, negative 4. And that's the answer, negative 4. That also makes sense because this is a linear equation with a slope of negative 4. The slope's never going to change. So at any point, the slope is going to be negative 4. So there you go, double verification. That's how you do it. Done. So for this one, we're trying to find the slope of the tangent line at a equals negative 2. So we are going to use our difference quotient. Check it out. So we're going to say the limit as h approaches 0 of f of a plus h minus f of a over h. And what is our a value? That is negative 2. So I'm going to plug in negative 2 into these two values. All right, now we're going to go back to this, and we're going to actually plug this in for x. So check it out. We have 2 minus 3 times negative 2 plus h squared minus f of negative 2. So again, I'm plugging in negative 2 there. Negative 2 squared is 4 times negative 3 is negative 12. 2 minus 12 is negative 10. So I'm just going to place that there nicely simplified. And then we have all of this over h. And again, this is the limit as h approaches 0. But now let's simplify. So we're going to have to FOIL this expression out, right? So that is negative 2 plus h squared, which is the same as negative 2 plus h times negative 2 plus h. Okay, let's simplify that. So negative 2 times negative 2 is 4. Then we have negative 2h, that's negative 4h. Last but not least, plus h squared. So all of this, again, is being multiplied by negative 3. I'm just trying to save some room here. So now we can rewrite this whole thing out. 2 minus 3 times all of this, which is, and then we're going to distribute that negative along. So it's going to be negative 12. Negative 3 times negative 4 is positive 12h. And then times h squared is negative 3h squared. Minus negative is a plus, so that's plus 10. And all over h. Now you're going to see that 2 minus 12 is negative 10 plus 10. Those are all going to cancel out to 0. And then we're going to divide these two terms, since they both have h. We're going to divide them both by h, and then we get 12 minus 3h. Now again, this is the limit as h approaches 0 of this expression. So now I can do direct substitution because now I've eliminated the h on the bottom. I'm no longer dividing by h. So plug it in. That kills that. And my final answer is 12. Okay, and then now we need to find the equation of the tangent line at x equals a. So we're going to make some room here. Now again, my coordinate is a is negative 2. That's my x value. When I plug it in, I get 4 times negative 3 is negative 12. 2 minus 12 is negative 10. That's, by the way, the same value that we got here, which is f of negative 2. And that's my point. My slope is the answer that I got here, which is 12. So now let's write it out. We've got y minus negative 10, which is plus 10, is equal to the slope times x minus negative 2, which is plus 2. That's my tangent line equation. That's how you do it. Done. So for this one, we're going to use the 3.5 equation, which is f of x minus f of a over x minus a. And this is going to be the limit as x approaches a. So let's write that out here. So my function f of x is 5x plus 4 minus f of a. So let's plug in negative 1 in for f of x. So 5 times negative 1 is negative 5 plus 4 is negative 1. So f of x minus f of a over x minus a. And then this is the limit as x approaches negative 1, which is my a value. So this is going to turn into a plus. This is going to turn into a plus. Let's simplify the numerator. We've got 5x plus 4 plus 1, which is 5x plus 5 over x plus 1. Now what you should try to do here is factor the numerator so you can simplify. Well, I can factor out a 5, so I get x plus 1 over x plus 1. Again, the limit as x approaches negative 1. These are going to cancel out, and we're left with a nice answer of 5. And guess what? This is my slope, or f prime of a, at a equals negative 1. And the reason why I know this is correct is because this is a line. The slope is always 5 at any point, at negative 1, at negative 10, at negative 1,000,000. So 5 is the answer. That's how you do it. Done. So for 27, we're going to use this formula, f of x minus f of a over x minus a, the limit as x approaches a. So let's start us off here. So we got f of x, which is 1 over x, minus f of a. A is 2, so plug 2 in right there. And then that is 2 in for x, which is 1/2, over x minus a. And this is the limit as x approaches a, which is 2. Okay, what we're going to do now is we're going to simplify. Now, to simplify the numerator, I need common denominator. So I'm going to multiply this one by x over x, and this one by 2 over 2, okay? And now we have 2 over 2x minus x over 2x. Now we have common denominators. I can merge this to become 2 minus x over 2x over x minus 2. Now we're going to divide, since we're dividing by this, we're going to keep change flip. So we're going to say 2 minus x over 2x. We're going to keep that. And since we're dividing, we're going to change that to multiplication, keep change, and then we're going to flip this to be 1 over x minus 2. Now we're going to try and simplify, right? This is very similar to this, but they're flipped. But if I factor out a negative 1, okay, that allows me to flip the signs, negate, negate. And why is that cool? Because then that's negative 2 plus x, which is the same as x minus 2. Why is that great? This matches up with this. They cancel out, and that's what we want. We want to remove that, okay? So now we have negative 1 over 2x. And again, this is the limit as x approaches 2. Well, now since we're not getting a 0 in the denominator, now we can do direct substitution, plug and chug. So 2 in for x gives us negative 1 over 2 times 2, which is 4. Negative 1/4 is the answer. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more videos from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining. We'll see you in the next video. Take it easy.